This is the fifth lecture on Lewis diagrams, and this one is on a topic called formal charge. Now remember that Lewis diagrams are models of how atoms form molecules. We now have 6 steps to follow now that we've added the slide, the electron pairs as needed step, and sometimes you have to use resonance so that the model will fit the data. A question can be raised. What happens when 2 or more Lewis diagrams work for a specific molecule? And this is different than isomers. For in isomers, you are creating different molecules. And for example, we'll use carbon dioxide. So we start with carbon dioxide and we'll walk through the steps. So we start with our NASB table, and here it is in all its glory. We figure out what's the central atom. There's carbon present, so it's going to be carbon. Now we're going to place the atoms, the carbon in the middle and the oxygens on the outside. We're going to put a single bond between the carbons and the oxygens. That uses up 4 electrons. Now we're going to distribute those electrons. I decided to put 6 around each oxygen. I could have put some around the carbon and fewer on the oxygen. But the key point is we don't have enough electrons so that each element has an octet. So now we're going to slide as needed. And so I'm going to opt to slide these 2 electrons over here and these 2 electrons over to here. And we end up with a structure that looks like this. Both oxygens have an octet with 2 unbonded pairs and 2 lines. The carbon also has an octet because it sees the 4 lines. Remember that each line is worth 2 electrons. However, I could have taken this pair and moved that here, and this pair and moved that here, ending up with something that looks like this. The first oxygen has 6 unbonded pairs and 1 line, so that's 8. The carbon has 4 lines. Each is worth 2, so that's 8. And the other oxygen has 1 unbonded pair, but 3 lines, so that's 8. This also meets the octet rule criteria. The question is, which one is the more valid? For that, we need formal charge. Now, it turns out formal charge makes one big assumption. It assumes that all electrons are shared equally. You calculate the formal charge for each element in the compound. You calculate it by taking the number of valence electrons for that element, then subtracting the number of unbonded electrons, and then subtracting the number of lines. As a double check, when you add up the formal charge for each element, you should get the charge on the substance. So the formal charge for a neutral molecule, when you add up all the formal charges, it should be 0. If it's an ion, it should equal the ionic charge. So let's take a look at our 2 possibilities. Well, let's look at the valence electrons. Oxygen has 6, carbon has 4, oxygen has 6, and so, as you would expect, we'd write 6, 4, and 6 over here. Then we look at the number of unbonded electrons, and we'll put a negative sign because we're subtracting them. So I've got 4 unbonded electrons here, none here, and this oxygen has 4 unbonded electrons. This oxygen has 6 unbonded electrons. This carbon still doesn't have any, and this oxygen now has 2. When you look at the number of lines going to the element, this oxygen has 2. Once again, we're going to put a minus sign because we're subtracting. This carbon has 4. This oxygen has 2. This oxygen has 1. The carbon has 4. This oxygen has 3. So now we're going to add up each column and get the formal charge on each element. So in the first structure, each of the elements has a formal charge of 0. If you add up the 3 zeros, you get 0. That is the charge on the molecule. It's a neutral molecule. In the second structure, we can see that we have a -1 on one oxygen, a +1 on the other, a 0 on the carbon, and the sum of those formal charges is also 0. So the double check is good. So now, using this, how do we decide which is the more valid structure? Well, the first step is you pick the structure where the formal charges are closest to 0. If you have 2 structures that are tied based upon this rule, then you go to the second rule. You pick the structure where the negative formal charge is on the more electronegative element. So if you look at these 2 structures, it's tough to be closer to 0 than all zeros. So we would say this is the more valid structure. Now, a note for the AP test. If you are asked to draw a Lewis diagram for carbon dioxide, and that's all they ask you, just draw a Lewis diagram, both answers would be accepted. If they ask for the most valid structure, then you would have to do the one with the 2 double bonds on the carbon. So make sure you read the question carefully. I'm going to have you do one for the thiocyanate ion. I'm now going to have you draw the possible Lewis diagrams. I will give you that, and there happen to be 3. 2 double bonds to the sulfur, 2 double bonds to the nitrogen, single bond to the sulfur, triple to the nitrogen, a triple bond to the sulfur, and a single to the nitrogen. I want you to figure out which one you think is the most valid form, then come back and we'll walk through it. Go. And this is the answer you should have gotten. How do you do that? Well, we start with looking at the valence electrons. Sulfur has 6, carbon has 4, nitrogen is 5. It's going to be the same for the other 2, so you just plug those in. Now you look at the unbonded. There are 4 here, none here, 4 here, 6 here, none here, 2 here, 2 here, none here, 6 here. Now we look at the lines. This has 2 lines, 4 lines, 2 lines. This has 1 line, 4 lines, 3 lines, 3 lines, 4 lines, 1 line. Now add everything up. The first thing we notice is that the sum of the formal charge for each structure is correct because they all add up to -1. Now we pick the structure where the formal charges are closest to 0. So that means you can eliminate this one. So with these two being equal, you pick the structure where the negative charge is on the more electronegative element. Nitrogen is more electronegative than sulfur, and that makes this the most valid structure amongst the 3 of them. So to review, the formal charge is a way of picking the correct Lewis diagram. In actuality, it has no actual physical meaning. It is simply a construct or a model that allows us to pick the most valid form. You look at the formal charge on a specific atom, and that's the number of valence electrons, minus the number of unbonded electrons, minus the number of lines going to that element. When you add up the formal charge for a structure, it should equal the ionic charge on the structure, or 0 if it's a neutral molecule. Pick the structure where the formal charges are closest to 0. If you have structures where that would turn out to be pretty much equivalent, then go with the negative charges on the more electronegative element. And that is how you decide which is the valid structure. Remember, if the question simply asks draw a Lewis diagram, they will accept any correct Lewis diagram. If they ask for the more valid Lewis diagram, they're actually testing you on both Lewis diagrams and formal charges. In the next lecture, we're going to start covering exceptions to the octet rule.